Okay, so for today, lesson 2.2, talking about the point slope form. We have three objectives for today. That by the end of the class, you'll be able to do three things. Number one, define the point slope form. Number two, graph linear equations using the point slope form. And three, to write linear equations using the point slope form. So we will start with our first, to define the point slope form. And you can see this is part of your notes. You can start filling this out. So just like the slope-intercept form, the point-slope form is an equation of a line. It's just a way of writing the equation of a line given certain information. And what information would that be? Well, you'll see that the point-slope form has the word slope in it. So just like the slope-intercept form, which we learned in the previous lesson, the point-slope form has slope in it, and it uses the same letter m. And you can see right there in our equation, y minus y1 equals m times x minus x1, that the slope is in the equation. Of course it is. It's called the point-slope form. So it has m, our slope, in it. But the point-slope form, unlike the slope-intercept form, which had the intercept, we don't have the intercept. But what the other thing we have is the point in the point-slope form. And the point is x1, y1, which is just a point on the line. So we can use the point-slope form if we have a point on the line, which we'll call x1, y1, and a slope, m. Then we just use the equation y minus y1 equals m times x minus x1. And that equation will be the equation of a line with the point x1, y1 and the slope of m. Give you a minute to get this down in your notes. All right, we said we had three objectives. The first objective was to define the point-slope form, which we have done right here. The second objective is to be able to graph linear equations using the point-slope form. So let's go through how to do that. We'll do it with an example of y plus 2 equals negative 4 times the quantity x plus 3, which again I'll rewrite up at the top here. And this looks pretty similar to our point-slope form. It's just a little different than y minus y1 equals m times x minus x1. And what's different is the signs. We have y plus 2, but we want y minus something. And we have x plus 3, but we want x minus something. So we're going to change the equation of y plus 2 equals negative 4 times the quantity x plus 3 into y minus negative 2 equals negative 4 times x minus negative 3. And this might seem a little weird because you've spent your entire pre-algebra lives, every time you've seen a minus a negative, like that y minus negative 2, your teachers always said, okay, well, minus a negative is a positive, so make that into y plus 2. Now all of a sudden we're going backwards. We're saying, well, let's take y plus 2 and make that into y minus negative 2. But the reason we're doing that is because now it is in the same format as our point slope form, y minus y1. So now it should be really easy for us to figure out the point, which is the first goal in our graphing. We begin with trying to figure out a single point on the line, x1, y1. And now that we have it in this form, it should be really easy to see that x1 is negative 3. Because it's x minus x1 and x minus negative 3. So that's why we made it minus negative, because now it's really easy to see that x1 and negative 3 are in the same place, just like y1 and negative 2 are in corresponding places. So we know what our equation is. If the x point is negative 3 and the y point is negative 2, then the point is just going to be negative 3, negative 2. So if we know that the point negative 3, negative 2 is on the line, then we need to graph that point. If it's on the line, then we need to graph it. So we go over to our graph and go to x negative 3 and y negative 2, and there it is. So now we have a point on the graph, and this is kind of similar to what we did the last lesson where we had the y-intercept. And except the previous one, it was always on the y-intercept. This point can be anywhere, but what you do next is the same thing, which is I have to figure out what my slope is. And hopefully from our equation above, it's easy to see that my slope is negative 4 because it's m times the quantity of the x's, and it's negative 4 times the quantity of the x's. So my slope must be negative 4. And I'm going to use my slope m to move. And where am I going to move? Well, I'm going to move using rise over run to find that second point. And of course, negative 4 is just equal to negative 4 over 1. So I'm going to rise negative 4. And rising negative 4, instead of going up 4, I'm going up negative 4, which is the same thing as going down 4. So I just have to count from my original point, go down. So I'm going up negative 1, up negative 2, up negative 3, up negative 4, or just down 4. And then I have to run. And I'm going to run 1. So from that, I'm going to run 1 out to here. There's my point. Now I have 2 points. If I have 2 points, I can just graph a line through them. But of course, negative 4 is not only equal to negative 4 over 1, it's also equal to 4 over negative 1. So if instead of doing it as negative 4 over 1, if I had done it as 4 over negative 1, then I'm going to, from that original point, rise 4. So I'm going to go 1, 2, 3, 4. And then I'm going to run to the right negative 1. And going to the right negative 1 is the same thing as going to the left 1. So running negative 1 is going to the left 1 or right negative 1. And there's my point. And now you'll see that whether I went down 4 and over 1 or up 4 and to the left 1, in either case, I get the same line. And of course I do. Those points are all on the line. So either way I did it, I would get the same line. Okay, we said we had 3 objectives. Our first objective was to define the point slope form, which we've done with the equation of y minus y1 equals m times x minus x1. The second objective was to be able to graph it, which is what we just did right here. You begin with finding the point, and then you move using rise over run to find a second point, and once you have 2 points, you can graph it. So we have 3 objectives, and our third objective is to be able to write linear equations using the point slope form. So in our notes we have this problem, problem 3b. Find the equation of the line with the slope of 2 and a point of negative 1, 5. So if we have the point and the slope, I'm going to use the point slope form, which is y minus y1 equals m times the quantity x minus x1. And my slope, I'm just going to put in right there for m. And my point, I'm going to put in there for x1, y1. So I'm just going to plug in those values, and when I do, I have y minus 5 equals 2 times the quantity of x minus negative 1. But of course, x minus a negative 1, we don't want to leave it like that. Minus a negative turns into a positive. So our final answer is just y minus 5 equals 2 times x plus 1. Well, this problem gave us a slope and a point. So obviously we're going to use our point slope form. However, sometimes it'll give us even less information than that, or different information, I guess I should say. It won't give us the slope and a point, but what if it gave us 2 points? If we have 2 points, then you'll notice we don't have a slope. So for example, in problem number 4 in your notes right here, it gives us 2 points, and it asks us to write the equation of the line. Okay, well, we only know 2 ways to write a line at this point. We know the slope-intercept form, y equals mx plus b, and we know the point-slope formula, y minus y1 equals m times x minus x1. But in both cases, they use the word slope in the definition because you need the slope. And right here, it doesn't give us a slope. But luckily, we know how to calculate the slope from 2 lines because we know there are 2 points, we know how to calculate a slope from 2 points because we know that the definition of slope is rise over run, or the difference of my y's over the difference of my x's. So I can just plug in my values here. y2 minus y1 is just going to be 5 minus negative 1. And x2 minus x1 is just going to be 3 minus negative 2. Just plugging in the values. And then, of course, 5 minus negative 1 is the same thing as 5 plus 1, that's 6. And 3 minus negative 2 is the same thing as 3 plus 2, that's 5. So now we have a slope. We have 6, 5 as a slope. So now we have the slope and we have a point, so we can use the point-slope form. So I'm going to use x1, y1 there. And so I'm just going to plug in my values. Y minus y1 equals m times x minus negative 2. I know what my m is. It's 6/5. And y minus negative 1 becomes y plus 1. And x minus negative 2 becomes x plus 2. So y plus 1 equals 6/5 times x plus 2. There's the equation of the line that goes through those 2 points. Okay, so step 1 was to find the slope, and once we had the slope, we picked a point and did it. But at this point, you may be asking, well, how do we know which point to use? Mr. Hayes, you chose x1, y1. But if I had labeled them differently and called 3, 5, x1, y1, I would have gotten a different equation. So let's find out. Let's do that. What if we use the other point, 3, 5? So if I take this same equation, except now I'm plugging in 3 and 5, I end up with a different equation. Y minus 5 equals 6 5 x minus 3. So which one of these 2 equations is correct? We've got 2 different equations. We want the right one. We want the correct one. How do we know which one is correct? Well, as I'll show you in a second, they're actually both correct. You could choose either one. Let me show you why. Let's change both of these into the slope-intercept form, y equals mx plus b. So if I take this first one, and I've got 6/5 there, that's ugly. I'm going to multiply the whole thing times 5. So I've got 5y plus 5 equals, distribute to 6, 6x plus 12. If I combine my terms or subtract 5 from both sides and now divide both sides by 5, I get y equals 6/5 x plus 7/5. And if I take that second equation and do the same thing, multiply by 5, I'm going to add 25 to both sides. I'm going to divide by 5 on both sides. I get the exact same thing. When I put them into the slope-intercept form, it's y equals 6/5 x plus 7/5. So if they're both the same equation, it doesn't matter which one you use. You could have chosen y plus 1 equals 6/5 x plus 2, or y minus 5 equals 6/5 x minus 3. They're both the same thing. So you could pick either point. It doesn't matter. You'll still get the correct answer. So you can pick either point here. It doesn't matter which point you choose. You will get the same answer. All right. So one more problem we want to go through, problem number 5. Because at this point, once again, we have talked about the point-slope form. We've talked about the slope-intercept form. But we haven't talked about the two special cases of horizontal lines and vertical lines. So to me, the easiest thing to do when you have a horizontal line or vertical line is just come up with some points on the line. So we know this horizontal line already has point 24. I'm going to put this point over here. That point is 0, 4. I'm going to pick this point here. Again, I'm just picking random points. That is negative 2, 4. I'll pick one more right over here. That is 5, 4. And so now hopefully you see there's a commonality here. What do all these points have in common? Negative 2, 4, 0, 4, 2, 4, 5, 4. What they all have in common is that y equals 4. And that's the equation of this horizontal line, y equals 4. What is x? It doesn't matter. X can be anything you want. X can be anything you want, but y is always equal to 4. That's any horizontal line is going to be y equals to something. In this case, it's 4. So the vertical line also going through 2, 4, which it shows there. Once again, I'm just going to pick some points on there. We've got 2, 4. We've got 2, 2. We've got 2, 0. Down here we have 2, negative 3. Well, what do all these points have in common? 2, 4, 2, 2, 2, 0, 2, negative 3. What they have in common is that x equals 2. So our equation is just going to be x equals 2. What's y? Anything you want. Y can be big, small, 0, anything in between. Y can be anything. But x always has to be 2.